I'm going to look at some examples dealing with surface areas of cylinders. And my first one is I have an ice cream bucket and I want to put paper around it. I'm going to wrap it for somebody's birthday, say that. So it's, first thing you got to think about is how much paper will I need, and then once you have that figured out, well, I guess not once you have that figured out, it's asking the question, well, how am I going to figure out how to calculate the amount of paper I need? So I'm going to need to know some things about my ice cream bucket. One, I would need to know, say, the radius, because I'm going to have a circle on the top and the bottom, or the left and right, however you want to look at this ice cream bucket with the cylinder. And then I'm going to need to know how tall it is, the height of it. Well, I can't really measure the radius, that's pretty hard. But what I can do is I can get out my flexible tape measure and I can measure the circumference, and I've done that. I measured the circumference of my ice cream bucket to be 64.5 centimeters. And then I get my ruler out and I can measure the height and find out that the height of that cylinder is 16.3 centimeters. Now I can use that information to help me find the surface area of my bucket so I know how much paper I need. Well, I think back to the circumference. I know that circumference is equal to 2 times pi times the radius. And then all I have to do is plug in what I know. I know that 64.5 is equal to 2 times pi times r. And then I need to solve my equation to figure out what the radius is equal to. So what I will do is I will divide both sides by 2 pi. When I do that, I find out that the radius is equal to 10.27. Now you have to be careful when you type that in on your calculator. You're going to want to type in 64.5 divided by 2 divided by pi. Sometimes people type in 64.5, they hit the divide sign, 2, and then they hit pi. What happens is the calculator is going to then multiply by pi, and you're going to end up with an answer that doesn't make sense. Just do a little mental math. 64.5, pretty close to 60. I know it's not exactly there, but I'm just doing some mental math. Pi is close to 3. Well, 2 times 3 in the denominator is 6. So I'm going to have 60 divided by 6. It's going to have to be somewhere around 10. If you get a number that's not even close to 10, check your work and you'll have that figured out. Alright, now, I have that done. So me, being the picture person I am, I'm thinking about my ice cream bucket, and it's going to be the rectangle and the 2 circles that I have to cover with paper. Well, I just figured out that the radius of each of these is 10.27. I already know that the height is 16.3 centimeters, and the circumference is 64.5 centimeters long. Well, the circumference, remember, is the same thing as called the length of my rectangle. Now I can go through to find my surface area, find the area of my 2 circles. So I'm going to do pi times the radius, which I found to be 10.27. Then I need to square it. And I'm going to think about that. I have 2 circles, so there's the area of 1. If I just multiply it by 2, now I have them both. And then I'm going to have to add on the area of my rectangle. Well, rectangle is going to be base times height. My base is 64.5. My height is 16.3. And I have everything that I need. Now it's a matter of punching things in my calculator. The first thing I've done is I've calculated the area of the 2 circles, and that came out to be 662.12. Now what I did is I took the 10 point, I think it was 26 something something something. I just squared that whole thing, multiplied it by my pi button, and I multiplied it by 2 and ended up here. I didn't round anything until I got to this point. And then the area of my rectangle is going to be 1051.35. If I add these 2 things together, I end up with a final answer of 1,713.47, and being I measured in centimeters, it's going to be centimeters squared. That's how much paper I will need to wrap my ice cream bucket. And here's the quadratic formula, something that's hopefully already been implanted into your brain, but if it hasn't, take that formula, it's down here, and implant it into your brain. Now remember, that's a way to solve a quadratic equation, which is right here. Get your quadratic equation equal to 0, one side, and then you can identify a as the number in front of x squared, b is the number in front of x, and c is your constant. Take those three numbers, put them into the formula, simplify the mess, and you'll be able to solve a quadratic equation. In my next problem, notice it wants us to find the radius. We have to figure out how long is that radius, and we know the height is 10 inches, and we know the total surface area of the cylinder is right here at 528 pi square inches. Well, you have a couple options. You can go your picture route like I would and draw the picture. We have this, our circle, and our circle, and then find the area of the pieces. Well, all we know is that the height of this is 10 inches. We don't know the length of the radius, which causes problems because we can't find the area of the circles and we can't find the circumference. So it is beneficial in this case probably to have that surface area formula. At least we can think about it. Maybe you don't have it memorized, but you can look at the picture now and go, well, I have my circle. To find the area of a circle, I have to do pi r squared. And being there's two of them, well, just multiply by 2. But then I also have the rectangle. So I'm going to have to add that on. The area of the rectangle is going to be base times height. Well, the base, remember, is the circumference of the circle. So that's 2 pi r. And I have to multiply it by my height. So maybe you don't have it memorized, but you can at least come up with it looking at the net. So now I'm going to take this formula and I'm going to plug in what I know. I know my surface area is 528 pi square inches. I'm going to leave the labels off for now. I can put them back in later. And that's going to be equal to 2 times pi times r. Well, we don't know that. That's what we're looking for. Squared. Plus, and then 2 pi. Well, there's that r again, the radius that we don't know. And then h, the height of the cylinder, that we do know is 10. And somehow we have to solve this equation for r. Well, I look at it and it has a squared variable, which tells me it has to be quadratic. So I might need to use this quadratic formula. We'll find out here in a little bit. Now the first thing I'm going to do is I'm going to look at this and say, I really don't like that pi in there. Or I do notice that it's on all three terms, so the first thing I'm going to do is I'm going to divide by pi. Actually, let's just go like this, divide the whole side. Now, I also look at each term and I notice that they all have a 2 in them as a factor, so I'm going to divide by 2 pi on both sides. And then what that does is that's going to make this look a little cleaner. So my left side now is going to be equal to 264. My right side, well, the 2 pi's are going to divide out of that first term, and all that's left is r squared. The 2 pi's are going to divide out of the right term, which is just going to leave me with 10r. Quadratic equation. Remember we said we had to get one side equal to 0? So I'm going to subtract the 264. That gets my left side equal to 0. Whoops. So I should subtract the 264 from this side as well. That's going to put me at r squared plus 10r minus 264. This is where we could use the quadratic equation. We could take our a value, which would be right here, it's a 1. Remember, when there's nothing there, it's understood to be a 1. Our b value would be the 10, and our c value would be the negative 264. That's one option. Now I look at this and say it's factorable. This side's still equal to 0, and when I say factorable, make a double set of parentheses. Being it's a 1r squared, I know that it's going to be r and r in my factors, and then I have to find the numbers that will add up to be a positive 10, but but multiply together to be a negative 264. I'm going to start with the negative part. Being I have to multiply to be a negative, I know one's going to have to be positive and one's going to have to be negative. And now those two numbers, if I take 12 and I multiply it by 22, I get 264. The question is, do I want the positive 12 or the positive 22? Well, being that the 10 is positive, I know that the larger number is going to have to be positive. So I'm going to that's a positive 22 and a negative 12. Now as I continue on to solve this, I'm going to set both of my equations equal to 0, or excuse me, not both of my equations, both of my factors. So r plus 22 is going to equal 0, and r minus 12 is going to be equal to 0. Now if I solve those two little equations, in this one, r is going to equal negative 22, because I would subtract 22 from both sides. Maybe I should show my work. And in my other one, I'm going to add 12 to both sides and find out that r equals 12. Remember, r stood for the radius. Well, if r is the radius, it doesn't make sense that it's a negative length, so that negative 22 I'm going to cross off and know that the radius of my cylinder in this problem is going to be 12, and then I'm going to come back up here and look at my labels. Everything was square inches and inches. Therefore, my radius is going to be 12 inches. And I have solved the problem. Now, my last problem that I'm going to look at, it's not a cylinder, but it's something that you're going to see in your accelerated math. This one is a right prism. You know that it has square bases. So I'm going to start here. I know it's a prism. Actually, I know it's a right prism. And I know that it has square bases. And it gives us some dimensions about this. Well, the first thing I'm going to look at is drawing the net. Well, if it's a prism, I know that it's going to have rectangular bases because it's a right prism. And being it has a square base, that tells me that there's going to be 4 of these rectangles. So there are the lateral faces. Now it's a matter of putting on my square bases. There's a square, and there's a square. Now what I do know about this is, I know the surface area, which means I'd have to add up the areas of every single rectangle and the 2 squares to get that, and I know the area of the square base is 23.04. Well, I think about the area of a square, and it's just base times height. Well, the base and the height are the same, so it's really base squared. And actually, I'm going to do this. I'm going to go with side squared. By square side of a square, I'm going to get its area, 23.04. So what I'm going to do then is I'm going to take the square root of that to figure out the length of one of the sides. I end up with a side length of 4.8 for my square. So I come back to my net, and I now know that this is 4.8, and I know that this is 4.8. Well, that means that this edge is also 4.8. Same thing here, same thing here, because all of those lateral faces are going to touch the square. The only thing I don't know is the height of my prism, which would be right here. Now, if I knew the height, it wouldn't be very hard for me to calculate the perimeter of that rectangle, which is one of the lateral faces. So I'm going to have to figure out what is the height of my prism. And the way I'm going to do that is I'm going to go back to my surface area. Surface area is the area of all the faces added together. Well, I know that this one has an area of 23.04. This one has an area of 23.04. But it's all of the rectangles that I don't know. But what I do know is that if I take base and I multiply it by the height, I'll get the area. Well, my base is h, my height for each rectangle is 4.8, so that'd give me an area of 4.8h for every single one of these rectangles. And now what I need to do is I need to add all those together. So if I add them all up, I have 23.04, I have 2 of those. And then I have 4 of the 4.8 h's. If I don't run out of room, there's 3 of them, and there's the 4th. So there's my surface area. But I do know that that surface area is equal to 199.68, based on what it told me in the problem to start. So I'm going to set this entire equation equal to 199.68. And now I have an equation to solve. So far. So the first thing that I'm going to do is I'm going to subtract the green 23.04, 2 of them. So really what I'm going to do is I'm going to end up subtracting 46.08 from both sides. Now, when I do that, I end up with 153.6, and then equals, and now I take that 4.8 and add it up 4 times, I will end up with 19.2 H. Well, divide both sides of my equation by the 19.2. I end up with H equal to 8. I'm going to come back up here, and H, or the height of my prism, is now 8. And remember, the ultimate goal here was to find the perimeter of one of the lateral faces. That's that green rectangle that I had highlighted earlier. Now I know that the base is 8, the height is 4.8. We've got to find the perimeter of it. Well, my perimeter is going to be equal to all the sides added together. So I'm going to have an 8, an 8, a 4.8, and a 4.8. When I add all that together, I end up with 25.6. Now I just need my label. So I come back up here, and everything was in terms of centimeters and square centimeters, which means my perimeter is 25.6 centimeters. Yes, the problem does take a little bit of time, but if you can take and put all the little pieces together, it's a problem that you are very capable of doing. And that's going to conclude my example portion of surface areas of cylinders and another surface area problem dealing with prisms.